share my screen. So I want to make a couple of announcements before we get started tonight. First of all, we will not meet next Thursday. My daughter has been selected to be part of a performance at the Cobb Energy Performing Arts Center, and it is at 8 o'clock next Thursday. So we will not have Zoom class. I will post a previous Zoom recording that will cover the topic, which is the 1 mean and 2 mean proportion test. So you guys will need to review that and then work on quiz 11. There is a bonus opportunity for you, and let me go over to the course page. I posted this, I believe, Monday. I received notification that the evaluations for the semester had been released, and that email is sent to your Georgia Highlands College email address, not to D2L. And you should have a link really for all of your courses. This is Business 3000, so you should definitely have a link for Business 3000. It's going to ask you questions like, did you start on time? How did you like the format? Did you like the tech? You know, all that kind of stuff. It gives you, some of them are multiple choice or, you know, ranking, you know, agree, disagree, those type questions. It also allows for open-ended comments, so you're welcome to make those good, bad, or otherwise. I do not see the results of that survey until well after grades are posted. Whatever comments are made are typewritten, so I don't even see, I don't have any way of knowing who says what unless you self-identify. And so please take advantage of that. Again, you can earn 5 bonus points. Those points are simply added to your point total before I do your average. You have until May 1st to do that. So please be sure you check your Georgia Highlands email for that link. Quiz 10, which will cover correlation and linear regression and Spearman rank, which is our topic of discussion for tonight, is due by next Wednesday, which is April the 19th. And mini project 6, which will cover linear regression, the topic we're talking about tonight, is due on Sunday, April 23rd. Do you have any questions before we begin?
No.
Okay. We are about to begin the last unit within the course. We are beginning Module 4 tonight. And the first lesson is linear regression and Spearman rank. And then next week by video, you'll have 1 and 2 proportion test. And then the last week, we will do the chi-square test. And then you'll have your final exam. Remember, the final exam is not proctored, which means you can use your notes and your resources within the course to take that final exam. Within the lesson for linear regression, I have the PowerPoint, but I also have a set of fill-in-the-blank notes similar to the notes that we used for hypothesis testing. Correlation and regression is a kind of a very lockstep process. You kind of do the same steps over and over and over and over again, like we saw with hypothesis testing. So I have those outlined in fill-in-the-blank notes, and there are examples at the end. So I'm going to use those tonight to do the discussion for correlation and regression, and then we'll get into Spearman rank. Spearman rank is the non-parametric test that is comparable to correlation and regression. So I just want you to be aware of that. The process for Spearman rank will change slightly, again, because it compares medians instead of means, but it is the non-parametric form of correlation and regression. So you'll know what's coming. So I'm going over to that fill in the blank notes. You may have them pulled up on your computer, or you may have printed them out where you can fill them in. This particular lesson, this is one of the first times in the course that we're going to deal with what is called bivariate data. Okay, this is one of the first times in the course that we're going to deal with bivariate data. Up to this point, we have only dealt with one variable at a time. Even when we were talking about ANOVA, when we had multiple groups, we still were only talking about one variable. We may have had the GPA variable sorted by pathway, but we still only had one variable. So up to this point, we've only really talked about how to analyze one variable at a time. But in reality, we oftentimes need or want to analyze multiple variables at the same time. And it's possible to do. We just don't have the time in either Stat 1401 or in this course to go much beyond that. If you choose to go into a field where you are going to use a lot of statistics, then you can take entire courses that would allow you to dig deeper into some of these topics. But I hope you realize that the prefix bi means two. So bivariate data means we're going to have two variables that we're going to consider at the same time. Okay, so we're going to have two variables considered at the same time. And it's correlation and regression. It's actually two different procedures. We do correlation first, and then we do regression. But the processes together are used to determine if a relationship exists between two quantitative variables. Okay, so we're looking at two variables at the same time, and both of them are quantitative. Remember, quantitative implies that they're going to be numbers. And we're asking ourselves, is there a relationship between those two variables, or are the two variables related in some way? And if you think about it, the word correlation implies that that's what you're doing, because the prefix co means with. So we have with relation. So the word itself, correlation, gives you kind of a clue that we're looking for a relationship. And I've given you several examples there. Is the volume of sales for a given month related to the amount of advertising for that month? Is a student's score on the first exam related to the number of hours that a student studies? Is the lifespan of an elephant related to its birth weight? is a person's age related to his or her blood pressure? So those are all worded the same way. We could word them a little bit differently and say, is there a relationship between age and blood pressure? Is there a relationship between the volume of sales and the amount of advertising? Okay, so again, we're looking for a relationship between two quantitative variables. Once we've made that determination, then we go a step further and we create a model of that relationship. The first procedure is called correlation. The correlation procedure determines if a relationship exists, between the two variables. And ultimately, you're either going to answer, yes, there is a relationship between the two variables, or no, there is not a relationship between the two variables. Once we decide whether there is that relationship or not, then we proceed to the next step, which is regression. The regression procedure creates a model of the relationship. And in this particular course, our focus is going to be solely on linear regression, or looking for a linear relationship. Now, a linear relationship is not the only type of relationship that can occur. You can have quadratic, you can have logistic, you can have exponential, you can have a variety of relationships. If you were to take a course specifically in correlation and regression, then you could or would consider those other options. But we're nearing the end of the semester, so we're short on time, and linear is the simplest of those types. So that's why we focus only on it. The idea of creating a model is an idea that kind of carries over from your algebra days. In algebra, you may recall being asked a question like, find the equation of the line that passes through, and then usually you were given 2 points. So you might be given the point 1, 2, and then say 5, 7. And the question in algebra was to find the equation of the line for those two specific points. Well, that idea of finding the equation of the line is what we are going to do in statistics, but we call it the model. And instead of using 2 points, we may have 5 points or 10 points or 20 points. So this is one of the few topics within statistics where there is an intersection between algebra and statistics. Now, don't panic. I know it may have been a while since you've had algebra, but Minitab does most of the algebra work behind the scenes for us. So let's focus on the relationship, the correlation procedure first. If you're thinking about, well, how do I know that I need to do the correlation procedure? Again, you're going to have a question similar to the ones that we had back up there as an example. It's going to say, is there a relationship between the two variables, if I'm very generic about it. Okay, ideally you would list out those two variables. But the question that we have to think about is there a relationship between these two variables? And ultimately, I've got to say, yes, there is, or no, there's not. So the first step in that process for deciding, is there a relationship between the two variables, is we have to first decide what role each variable is going to play. You have what's called the independent variable. The independent variable is usually represented by the letter X. Your data is often presented in a table form so that you have your values for X in one column and your values for the other variable, which we call Y, in the other column. And typically, so that everybody's kind of on the same page, whether you're in Cartersville, Georgia, or Atlanta, Georgia, or Paris, France, or Sydney, Australia, usually the independent variable is in the left-hand column or the top row of a table. Now, that's not a requirement. Notice it says usually. Couple of things I want to tell you. Minitab uses a different word for your independent or your X variable. It calls it the predictor. One of the things that you need to know about the independent variable, the independent variable is the variable that you can choose, change, or manipulate. So again, think about it from an algebra perspective. In algebra, you may have seen equations like y equals x plus 3, and then you may be asked to create a table of possible answers. And normally when we do that, we would choose values for x. So the x would be our independent variable because it's the one that I'm able to choose or change from scenario to scenario. Once you've identified the independent variable, by default, the other variable is called the dependent variable. And it's usually represented by the letter Y. And again, for commonality, usually that variable is going to be in the right-hand column or the bottom row. Again, Minitab uses a little bit different terminology. Minitab calls the dependent variable the response. It's important that you can identify which variable is the independent and which variable is the dependent. Okay, it matters. And if you don't identify it correctly at the beginning, then that messes up your calculations later on. There's a couple of ways to make that decision. And from earlier discussions that I've had today, students tend to grasp one way better than another. There is this little saying where we could fill in the blanks and say something like the Y variable depends on the X variable. So for example, if we're thinking about the question about the volume of sales and advertising. Okay, we could say the volume of sales depends on the amount of advertising. And then we would have to kind of maybe ponder, does that make sense? Well, in my mind, it makes sense because the amount of advertising would be the variable that I could change. If I'm the person that owns the company or the person that's responsible for marketing, I can control or change or manipulate how much is spent on advertising. And I would like to think that the amount spent on advertising, as it goes up, my sales are going to go up. Now, ideally, that's what happens. Okay. So it makes sense to me because, again, I'm thinking, okay, the advertising I can manipulate or change, and that's going to control or determine my volume of sales. What I found earlier today is students really relate to it more so if you just think about which variable can you control. So if I scroll back up here to the examples we had earlier, and if we think about this idea of a person's age related to his or her blood pressure, and I think about which one of those things, age or blood pressure, could I change, control, or manipulate? Well, I can, in some ways, control a person's blood pressure. Okay, so the blood pressure is the independent, okay, and the age would be the dependent or the Y. I can control the number of hours that a student studies, or you as the student could control how much you study. So that would be my X or my independent. And so by default, the score on the test would become the Y or the dependent. Okay, so it's important that you're able to identify which one is the X and which one is the Y. Now, I will tell you, Miss Ralston is usually pretty nice about this because I do use those standard guidelines in that the left column or the top row represents the X, and sometimes I'll even label it X. And the right-hand column or the bottom row of the table represents the Y. And again, sometimes I even label it Y. Okay, so pay attention to the setup of the question because you may have that information provided for you. After we've identified which variable is which, and again, it does matter, we're actually going to create a scatter plot. Now, scatter plot is a new term. It is a type of graph or a visual display of your data. And because we have two variables, okay, we have to have two number lines. So we have a horizontal number line, which typically represents the X or the independent variable. Again, this is a carryover from algebra. And the second number line runs vertically, and it represents Y, or the dependent. That's the same old that you had in algebra. It hasn't changed. You have two number lines. One runs horizontally, one runs vertically. And then we would plot our data points. Now I'm making these up because I don't really have any data points at this point. But then you plot your data points. So that's why it's called a scatter plot, because you're plotting the data points and they are scattered on the graph. It's called a scatter plot. Now, you are not going to do this by hand. Okay, you're not going to do this by hand. We will use Minitab to create that graph. Once I have that graph, I am going to use, let me see if I can, okay. I don't think I can do it that way. We're going to use our eyeballs and our gut, and we're going to ask ourselves 3 questions. Okay, so we create the scatter plot, and then we're going to use our eyeballs and our gut, and we're going to ask ourselves 3 questions. The first question that we ask is, does there appear to be an overall pattern within the data points? And you're either going to say, yes, there appears to be some sort of pattern, or no, there does not. And again, that is solely your personal interpretation based on what you as an individual see. And guys, we could disagree. I could look at it and say, yeah, that there looks like a pattern to me. But then Deidre might look at it and say, no, I don't think there's a pattern. Okay, so eyeballs and gut can have disagreement from person to person. Even if I say no, I'm going on to the second question. The second question says, does the overall pattern appear to be linear? Again, we're asking that particular question because we're focusing only on a linear regression or a linear pattern. And again, you're either going to say yes or no. And again, what I'm doing, if we look at the example that I kind of rough sketched up here, is I'm imagining, could I draw a line kind of through some or through the middle of those data points? Then the third question we ask is, does the linear pattern appear to be positive, negative, or 0? In this case, you're thinking about the slope or the tilt of the line. Remember, the slope, hopefully you learned in algebra that the slope measures the tilt or the slant of the line. Let me review those options for you and what it would look like if you were looking at a graph. If you have a scatter plot that has a linear pattern, it would have a positive slope if the dots appeared to go up as you move left or right. Okay, so a positive slope appears to move up as you move left to right. A negative slope would appear to go down as you move left to right. So a negative slope goes down as you move left to right. And then lastly, you could have one with a zero slope. Zero slope would appear to be a flat line or a horizontal line. Basically, you wouldn't have any kind of change. Okay, so it would be horizontal. So again, you're going to create the scatter plot. I'm going to show you how to do that in a few minutes. You want to kind of take a step back and look at the big picture. Okay, you don't want to have tunnel vision here. You want to look at the big picture. And you're going to ask yourself, does there appear to be an overall pattern? Is that pattern linear? And then is that linear pattern, positive, negative, or zero? But remember, we're doing all of that with our eyeballs. And again, we could have disagreement. My eyeballs could see one thing and Deidre's could see another. So we do not rely solely on our eyeballs. If you'll recall, we've talked about this as well. You always want to verify with the numbers. We verify using an algebra technique or calculating a statistic. Now, Minitab's going to do the calculations for us. Okay, so we won't get too panicky about that. Okay, but we are going to use app.minitab.com. The value that we're going to calculate, and I'm going to go down here, just skip for just a minute. The statistic that we're going to calculate is formally known as the Pearson's product moment correlation coefficient. That's the fancy dancy name. Pearson was a German statistician. His first name was Carl. So Mr. Pearson was the one who kind of described initially this relationship. The Pearson's product moment correlation coefficient is a numerical measurement of the strength and direction of the linear relationship. One of the things that I want to emphasize is that this only works or should only be used if you believe you have a linear relationship, that pattern is linear. Because this particular statistic is only applicable to linear relationships. Now, we don't often use the fancy dancy name. You have, a lot of times we'll just shorten it and call it the correlation coefficient. But you have a sample linear correlation coefficient. We can calculate that particular statistic for a sample. Remember, for a sample, the symbols are English letters, and for the correlation coefficient, it is a lowercase r. A lot of times you may hear people just say, excuse me, I'm going to calculate r. You can have that same measurement for the population. Remember, for the population, we use Greek letters, and this is the Greek letter rho. It looks like a lazy P. Okay, it looks like a lazy P. It's kind of tilted over a little bit. So regardless of whether you're talking about the population linear correlation coefficient or you're talking about the sample, the value of your correlation coefficient will always be between -1 and +1. Now, that may not be as important to you as it was to me, because I was having to do these calculations by hand. So if I got to the end of the problem and had a value, excuse me, that was larger than 1, I knew, whoops, I've made a mistake. Or if I had a value less than -1, then I knew I had a mistake. But I want to talk about what those numbers mean for just a minute. Okay? It's a range. It's like a graduated scale, like we've talked about several times, sort of like we talked about with probability. We have -1 on one extreme, and we have +1 on the other extreme, and of course 0 in the middle. If we were to have a correlation coefficient of exactly -1, visually what I would have is I would have my data points lined up in a perfectly straight line that runs downhill or down as I move left to right. That's called a perfect negative linear correlation. On the other extreme, if I had a value of +1, I would have, again, my data points lined up, one right behind the other in a perfect straight line, and it would appear to go up as I move left to right. That would be a perfect positive linear correlation. Now, guys, in reality, we don't have perfect linear correlations very often, if at all, whether it's negative or positive. But I can have any value in between. Okay, so if I'm thinking about that, if we're close to -1, that means we have a strong negative linear correlation. If you kind of get in the middle, we would say moderate. So somewhere around, say, -0.5. And then the closer you get to 0, it's weak. It also works that way on the flip side. If I'm close to 0 on the right side, it's still weak. It's a weak positive. If I'm in the middle, it's called moderate. Again, moderate, I'm thinking somewhere around 0.5. And the closer I am to +1, the stronger the relationship. If it happens to be exactly 0, okay, if it's exactly 0, one of two things is happening. Either I have a pattern within my dots or within my points, but my pattern is not linear. It could be quadratic, it could be exponential, or it may have no pattern whatsoever. Okay, where it's just a bunch of random dots. Okay? Now, at least with the linear correlation coefficient, we have used the actual data values to calculate that measurement. And it tells us whether it's positive or negative, the direction. And it also tells us whether it's weak, moderate, or strong. Okay. But again, if we're just kind of using that number line, what I view as moderate, you might see as strong. So we're still not fully convinced. So we have to, again, double verify, if you want to call it that. I don't know if that's what you want to call it, but it's kind of like a double verification. Okay. So we have a double verification. The number that we get for the linear correlation, okay, that makes me feel a little bit, hold on just a second, makes me feel just a little bit better. But I want to be really, really, really confident that I do have a relationship or I don't have a relationship. So the double verification is a hypothesis test. Okay. So we've looked at the scatter plot. We've calculated the linear correlation coefficient. And now I'm going to double verify that there is or is not a relationship. We're going to determine if there, well, not there, excuse me. If R, which is your linear correlation coefficient, is statistically significant using a slightly modified hypothesis test. And again, the idea of it being statistically significant is the value of R different enough from 0 to say without a doubt, yes, there is a relationship. Now, as you should know by now, in a hypothesis test, the first step is to state the hypotheses. And for this particular hypothesis test, the hypotheses are the same every time, all the time. You have your null hypothesis, which must contain 0. And we would say that rho, the population linear correlation coefficient, equals 0. But that means there is not a linear relationship and R is not statistically significant. Now, guys, that is backwards to what your brain would tell you, because your brain would tell you if it's equal to 0, it's got to be statistically significant. But go back up here to what I just drew. Remember, I said if it's 0, either we do not have a linear relationship or we have no relationship at all. So in this scenario, 0 is bad. The alternative hypothesis would be that rho, the population linear correlation coefficient, does not equal 0, which means there is a linear relationship and R is statistically significant. I'm actually testing whether it is or is not significant. Okay, but again, it's kind of the opposite of what your brain would tell you when you look at the numbers. The null hypothesis for this particular hypothesis test for correlation is always and forever rho equals 0. The alternative is that rho does not equal 0. Then we're going to use Minitab to calculate the test statistic and its p-value, but we only really need the p-value here. Okay? It's going to calculate the test statistic, but I don't need it. Okay? You still have to make the decision on whether you're going to reject the null or whether you're going to fail to reject the null by comparing that p-value to the level of significance, and we will always use alpha equals 0.05. The other piece that changes here is how you make your conclusion. Ultimately, your conclusion is going to be, is R statistically significant? And you're either going to say, yes, it is, or no, it's not. And so then kind of the next step, which is tied to that hypothesis test, is to conclude if there is, there is a relationship between the two variables. And again, you're going to answer yes or no. Okay, here's the deal. If you answer yes, there is a relationship, then you're going to continue on to the regression procedure. But if you answer no, you stop. You can't go any further. You use the average or the mean of the Y values for prediction purposes. If you determine there's not a relationship, then you cannot find a model of that relationship because the relationship doesn't exist. And you can't find something that doesn't exist. So if we answer yes, then we move to the linear regression procedure. And again, Minitab is going to do all of that for us. We're going to determine the model of the relationship in the form. The notation looks like this. Y prime equals B plus AX. Now, hopefully, that looks sort of familiar, because if you think about it, think about your algebra days. In algebra, when you were asked to write the equation of a line, we usually wrote it in the form y equals mx plus b. Well, they've changed the notation just a little bit. The y prime is an indication that we used linear regression, which means we've used, 5, 10, 20 different points. In algebra, where we just use plain old y, we used 2 points. Again, in algebra, the b was known as the y-intercept. That was kind of like your starting value. It's the same thing over here with regression. It is technically your y-intercept. It is the value at the beginning, your starting point. In algebra, the m, remember, was called your slope, which measures the tilt of the line. And we calculated it with 2 points. A stands for the average rate of change, which is basically the same idea as slope, but I've used lots of points, not just 2 points. That's the difference. It's just a slight change in the terminology. Minitab is going to do the calculations for you. But again, algebra intersecting with statistics. Once I have this model, okay, I can then use that model to make a prediction. Okay, I can use the model to make a prediction if I'm given a value for X. And I don't remember what this is supposed to be. Usually you're given a value for X, so I can then make a prediction. That's kind of the whole point of correlation and regression. I want to be able to see if there is a relationship. If there is, I want to create a model. If I can create a model between the amount of advertising and the volume of sales, I can then predict if I spend, $1,000 on advertising, I should expect this amount in sales. But the other thing is, sometimes we find there is a relationship and we create this model, but is it appropriate to use that variable? Is it appropriate to use the amount spent on advertising to predict the volume of sales? Is it appropriate to use a person's blood pressure to predict their age? Sometimes the model, yeah, I can find a model because there's a relationship, but should I? There's an example in a textbook that we used to use that looked at whether or not there was a relationship between ice cream sales and the number of crimes during the summer months. And it was determined there was a relationship, But what does ice cream sales have to do with crime? So it becomes a question of, should I create this model? And so that's where the last two steps come in. This is where we're thinking about, should I create this model? And I suppose it's kind of weird, but it's at the end. I guess we should have asked that maybe early on, but this is kind of where you're asking, should I use the model that we've created? The question is usually worded, is the amount of advertising a good predictor for the volume of sales? Is blood pressure a good predictor for the age? And we determine that by looking at what's called the coefficient of determination. And the symbol for the coefficient of determination for a sample is R squared. Literally, I could take the value that we got for R back up in part 1 and square it. Now, Minitab's going to do it for us, okay? But it's called the coefficient of determination, okay? We're either going to say, yes, it is a good predictor, or no, it is not a good predictor. And this is one case where Miss Ralston is going to kind of let you wave your hand, wave your wand to make a decision. The rule of thumb that we're going to use in this class is if R squared is greater than 50%, we're going to say yes. If R squared is less than or equal to 50%, we're going to say no. Okay, it is the one time that I'm going to let you use kind of your gut instinct with some guidance. Then the last step is you're going to actually interpret that coefficient of determination. What does it mean in the context of the problem? There is a very, very specific way to write this answer. You would say approximately R squared percent of the variation. Notice the word is capitalized in big letters. That means it's an important word. Variation in the Y variable is determined by the variation. Notice big letters, capitalized, important word, in the X variable. All right. Now, that's a lot, and I realize that. But the process is very lockstep, and the way the questions are set up on, I believe, on your homework and on your test are set up to walk you through the process. Okay? So let's look at an example and kind of put these steps in context. It says, the following are advertised sale prices of color televisions at an electronics store. And it gives you the size of the television and then the sale price. Is there a connection? Is there a relationship? Is there a correlation? between the size in inches of color televisions and the advertised sale price. So the first thing you have to decide is, I suppose you may want to figure out which test you're doing or which process. The biggest thing that jumps out at me is that I have two variables: size and cost or price. Correlation and regression is the only topic that we discuss where you have two variables. Got to be correlation and regression. We start with correlation. We have to first identify the independent variable. Again, if I can think about it in several ways. Between size and sale price, I need to think about which one of those I can control, change, or manipulate. And I hope you realize that's going to be the size in inches. I also notice that that is the information that's on the top row of the table. And Ms. Ralston had already told you that she follows the standard guidelines, that the top row is the independent variable. So by default, my dependent variable is the sale price, which is in dollars, and that's the Y. Then it says, use Minitab to create a scatter plot to answer the following questions. Okay, so we got to create a scatter plot in Minitab, but to do that, I need to give you the keystrokes. We go graph, and then scatter plot, and then I'll have to look it up because I don't remember. Now, obviously, before you can do anything, guys, you have to enter the data. When you enter the data, you have to keep them paired together this way. 9 has to correspond to 147, 20 to 187. So I would type in and put my size in my first available column and the sale price next to it. You should know how to enter data by now. Maybe this will come back. I had typed it in earlier. Let's see if it erases it. It did. Okay, so I've got to retype them in. And here's what I would tell you to do, guys. I'm going to put size or TV size. TV size is in inches, and I'm going to label that as X. Because throughout this process, Minitab's going to ask me which one is independent, which one is dependent. So if I label them from the beginning as X and Y, I don't have to keep going back trying to figure out which one is which. Okay, so I like to label mine X and Y in Minitab. So let me enter these numbers again. I have them printed out so I can look at them. I don't have to keep toggling back and forth. Again, you have to keep them paired the way that they're given to you in the table. The pairing is important. Okay, so I've entered the data. I want to create a scatter plot, which is a graph. So I go graph, scatter plot. We keep it simple. And then I have to indicate where is the Y variable, where is the X variable. Okay, Y is the sale price, X is the TV size. And then I'm going to click OK. Now let me go over here and write those strokes down for you so you'll have them. Okay. So we go scatter plot, graph, scatter plot. We want to keep it simple. You have to double click. You have to do the location of the y variable, location of the x variable, and then click OK. And I'm going to bring that scatter plot over here to this paper so we can look at it. Okay, so there's our scatter plot. Okay, I didn't fancy up the title or anything like that. I really should have, but I didn't. Okay, so the TV size is my X, the sell price is my Y. Okay, so here's my dots, my points. So I'm going to ask myself 3 questions. I'm going to look at this graph and I'm going to answer these 3 questions. Does there appear to be an overall pattern within the dots? I'm thinking yes. So I'm going to say yes. Does it appear to be linear? Again, the idea of it being linear is, could you imagine maybe drawing a line through some or maybe none of these points, but kind of hitting middle of the road? I'm kind of on the fence there, okay? But I'm going to say no. I'm not sure. It kind of looks like it's curved a little bit. But if it did have a linear pattern, notice it does appear, excuse me, that as the size goes up, the price goes up, which means I have a positive slope. Okay, so I have a positive pattern. So I'm kind of mixed. I agree that there's a pattern. I'm kind of iffy on whether it's linear, but it does appear to be positive. Okay, so then I'm going to calculate the linear correlation coefficient. And let me make sure I remember how to do that. Yep. Okay, we go to, let me give you the keystrokes. It is stat, basic statistics, correlation. Then I believe we select the 2 variables, but let me be sure. Okay, so we have our data entered. We're going to calculate the correlation coefficient. It's stat, basic statistics, correlation. It's near the bottom, correlation. And then I choose the 2 variables. The order in which you choose them really doesn't matter, okay? Select the 2 variables. And then we're going to click OK. Okay, so I've selected my 2 variables. I'm going to click OK. It actually comes up in graph form again. And I'm going to copy it over so you can see it. Okay, it actually gives you the graph again. The piece that you need is this R that's kind of underneath that graph. It says R equals 0.8 Okay, so my R is 0.894. Now, if I'm thinking about that from my gut perspective, and I go back up here to this scale that Miss Ralston drew, think about where 0.894 would be. Positive 0.894 is going to be somewhere over here. I'm reasonably close to 1. So I would say from my gut, okay, from my gut, that this is a strong, positive, linear relationship. Positive because the value itself is positive. R only measures a linear relationship. And my gut's telling me it's strong because 0.894 is close to 1. Now I got to prove it. So the next part tells me to conduct the hypothesis test to prove that R is statistically significant. My null hypothesis will be rho equals 0 and rho does not equal 0. But again, it's important that you understand what that means. If rho is equal to 0, that means there is not a linear correlation and R is not statistically significant. If it's not equal to 0, there is a linear correlation and R is statistically significant. Okay. Really, all you have to write is rho equals 0 and rho does not equal 0. But guys, you got to understand what that means. Okay, so then I've got to do the hypothesis test. Now, when I do this hypothesis test, I'm going to get the information that I need to do the rest of the problem. Okay, I just have to look at different headers or different pieces of the results. Okay, so to get the p-value for my hypothesis test, we're going to do I believe it's stat. Let me make sure. Stat. Yep. We do stat, regression, Let me be sure. I think it's fit regression model. Yep. Fit regression model. You're going to have to tell the location of Y, which Minitab calls the response, location of X, which Minitab calls a continuous predictor, and then I can't remember. Stat, regression, fit regression model. My response is the Y. The continuous predictor is the X. And from there, I believe we hit OK. Yep. Then we click OK. Now, again, at that point, you're going to get, you're going to get lots of information. And we're going to use various pieces to finish out the problem. So again, I went stat, regression, regression, fit regression model. Sell price is Y, which is the response. Continuous predictor is X, and I click OK. Initially, I'm looking for the p-value. And let me get to the right spot. For the p-value, you want to find the header that says analysis of variance. Okay, you want to find the header that says analysis of variance. And you have at the end the F and the p-value. Now, there are two of them, but they're the same. Okay, so the p is 0.007 for my test. Okay. Then, using that information, I'm going to make my decision on whether or not R is statistically significant. I'm going to compare my p-value from Minitab, which was 0.007, to alpha, which we always use 0.05. And I'm going to compare those, just like we've been doing. 0 is the first number after the decimal point in both values. Then I have 0 compared to 5. 0 is less than 5, so P is less than or equal to alpha. If P is less than or equal to alpha, we reject the null. If I reject the null, okay, we reject the null. That means the null is false and the alternative is true. The alternative is that rho is not equal to 0, which means there is a linear correlation and R is statistically significant. So the next question says, is the linear correlation coefficient R statistically significant? And we must say, yes, it is. Because we rejected the null, the alternative hypothesis is true. The alternative hypothesis says that there is a linear correlation and R is statistically significant. Question 6 then says, is there a linear correlation between the size of the TV and the advertised sale price? Again, we have to answer yes. Because we rejected the null, the alternative is true. The alternative says there is a linear correlation and R is statistically significant. Guys, the answer to 5D and number 6 have to be the same answer. It's the same thing. It's asking you the same thing in two different ways. So we know that we have a linear correlation, which means I can find the model. I've actually already found the model. When we did those steps, stat, regression, regression, fit regression model. If I scroll back up, the very first thing is the regression equation. And so there I have my equation. Do not leave it that way. An equation does not, should not have words in it. Okay, so I've got to write this out and leave out the words. So I would have y hat or y prime equals negative 749 plus 54.8x. Now again, now that I have numbers in there, let me reiterate. This number that doesn't have the x, remember, is your y-intercept. And the 54.8 is your slope or the average rate of change. There's my model. It comes directly from Minitab. Then it says predict the advertised sale price of a 55-inch color television. They're asking you to use the model. Use the model from number 7. Okay, so my model is y prime equals negative 749 plus 54.8x. The question asks me to find the price for a 55-inch color television. They're giving me the size of the television, which is the X. We are going to plug and chug. We're going to plug the value that we're given into that formula and do the calculations. So I would have y prime equals negative 749 plus 54.8 times the 55-inch television. I get my trusty dusty calculator, and I'm going to type that in just as I see it. Negative 749 plus 54.8 times 55 gives me a value. Y prime would be $2,265. So based on the model, a 55-inch color television would be on sale for $2,265. So we determined there was a relationship. We've created a model of that relationship, but should we have created a model of that relationship? Okay. That's when we look at the coefficient of determination. Again, Minitab has already calculated it using stat, regression, fit regression model. This time, I'm going to look for the header model summary. I'm going to look for the header model summary. Whoops, I got it in the wrong place. Sorry. See if I can. Undo that. And put it right here. Okay. On the model summary, we're looking for R squared, and we're going to use this one right here. So my R square is 80%. Using the rule of thumb that Miss Ralston gave you, I can see that this R squared is greater than 50%. And Miss Ralston said, if it is greater than 50%, we can say yes, that it is a good predictor. So the size of a color television is a good predictor for its advertised sale price. All I got to say is yes. Then the last step is where I offer the explanation of that coefficient of determination. And you basically have to fill in the blanks of that paragraph that I showed you earlier. So we say approximately 80%, that's the value of R squared, percent of the variation in the sale price can be determined by the variation in the color TV size. Guys, you have to write the word variation. And it's always variation in the Y to variation. It should be the word in, not is. Sorry, I got a typo. The X. Questions? Now, I realize that I've only done one example. I have videos of other examples that I will post, but I want to try to get to Spearman rank before we finish tonight. We've got about 30 minutes left. The other thing that I want to point out is you're going to be asked to do this on Mini Project 6. The hardest part for students, you're going to go exactly through those steps, is picking out the variables. Guys, you have to pick 2 different variables, both of which are numbers. If you will go to, let me get back over here, to Mini Project 6, and please look at the information and helpful hints that I've provided for the 2 data sets. For example, if I look at the heart disease data set, the information that I've provided in a Word document format, if you scroll all the way down, look, Miss Ralston has provided some suggestions. Is the resting blood pressure correlated to the age? Is the cholesterol correlated to the age? Is the old peak correlated to the resting blood pressure? Is the max heart rate correlated to the resting blood pressure? I give you 4 different examples. I'm sure there are others that you could do. Pick one. The easiest thing to do is to choose one that Miss Ralston has suggested, and then go through the steps just like we did on this problem with the TV size and the sale price. And I will post videos of additional examples because I would like to get to Spearman rank. Do you have questions before we go to Spearman rank? Okay, Spearman rank is again the comparable test to the Pearson correlation coefficient. Okay, it's less restrictive. Okay, Spearman rank doesn't just determine whether or not the relationship is linear. It determines what's called a monotonic relationship, and I'm going to explain that in just a minute. Whether monotonic relationship exists between two continuous variables or two ordinal variables. It's called Spearman rank because we look at kind of the ordering, the ranks of each data value or each set of data value rather than just looking at the raw data. It's named after actually a psychologist. His name is Charles Spearman. But just like the correlation coefficient, Spearman rank is also always between -1 and +1. And notice the slight change in the notation. It's still an R, but it has a subscript of S to indicate that we're using Spearman rank. The S for Spearman. This idea of being a monotonic relationship. Monotonic is a relationship that kind of does one of two things. Either as one variable increases, let me move this out of the way so you can see it. As one variable increases, see as it goes up, the other one goes up. Or as one goes up, the other comes down. So you can have the kind of that positive or negative, but it's only doing one of those things, and it doesn't necessarily have to be linear. This one here at the end, see, part of the time it's going up, and then other times it's going down. So this is not monotonic. So Spearman rank is less restrictive because we're not assuming that we have a linear relationship. We're just assuming that the variable is kind of doing the same thing all of the time. It's either always going up or it's always going down. There is a rule of thumb that is used for Spearman rank. This is the standardized rule of thumb that is used for Spearman rank. And these values are stated as positives, okay? But it could also be the negatives. And it gives you what type relationship you have. Very weak, weak, moderate, strong, or very strong. Okay, so it's kind of the same process. You still have to think about which one's the independent, which one's the dependent, that kind of thing as you go through it. Okay. So here's the first example. It says this table shows the average maximum sentence for certain crimes and the actual time served in months. And we want to know, is there a relationship between the sentence and the time served? Okay. It also tells us what the crime was or is. That's fine. I don't necessarily need that information, but I have it. Okay. So the first thing I may want to do, even with Spearman rank, is look at a scatter plot of this information. So again, I had earlier put the information into Minitab, but it disappeared. So let me get a new worksheet. I could put in the column for the crime, but I don't need to. I'm going to put in the sentence, and that's the month. And I'm going to put in time served. And again, that's also in months. I didn't label them X or Y. Okay, it's okay. 227, 120, 106, 77, 60, and 49. You do have to keep them paired as they're given to you. So if I create the scatter plot using the same clicks that I did earlier, graph, scatter plot, keep it simple. My time served is the Y, and my sentence is the X. And I'm going to click OK. And I'm going to take it over here to this paper. We get this scatter plot. I mean, I would think this almost looks linear. Again, thinking about whether it's monotonic or not, it kind of looks like it has a little bit of a dip, but you know, maybe. But again, remember, we don't rely on our gut or our eyeballs. We need to calculate our test statistic, which is the Spearman rank. Miss Ralston has forgotten how to do that, so give me just a minute. No. Oh, how terrible is that? Miss Ralston's forgotten how to do it. Oh, that's terrible. Non-parametrics. Guys, I'm sorry. I haven't done this one in a while, and I really don't remember how to do it. Okay, I'll have to look it up and let you know. So I'm sorry I can't even finish the problem because I don't remember how to do it. And I thought I would have had it in the PowerPoint, but apparently I do not. Okay, let's see if we can look real quick. If I can find it real quick. Hang on, give me just a second because I do have the keystrokes somewhere. Ha 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 ha. See, learning to use your resources. A good example, we have Minitab instructions, module 4. We want correlation and regression. And I need to know how to do Spearman rank. Aha! Stat, basic statistics, correlation, both the independent, dependent variable, options. All right, so let's see. That's what I thought, but I didn't do it correctly, I guess. Okay, so we go to Minitab, Stat, Basic Statistics, Correlation, choose these two, Options. Oh, here it is, right here. See right here where it says Method? See the method? I'll write it down for you. We want Spearman. Okay, so let me come over here and write it down for you. I used my resources. Okay, so here are the clicks for calculating Spearman rank. Okay, for Spearman rank, it is stat, basic statistics, correlation, okay, choose the two variables, we go to options, and next to method, we want to change it to Spearman correlation. Initially, it was set to Pearson, and I didn't have to change it because it defaults. But now I have to change it. And you're going to click OK 2 times. I apologize. I don't do it every day. Okay, so let's walk through it again. Stat, basic statistics, correlation. I choose the two variables. I click on options, and I'm going to choose the Spearman correlation instead of Pearson. And I'm going to click OK. And I'm going to click OK. And again, it comes up in a graph form. Let's see if I can get it to let me put it up. It's not going to let me do it. And again, the number that you want is this R value underneath the table or underneath the graph. But again, notice in the header, it's telling you that this is Spearman. So for this problem, my Spearman correlation is 0.943. So if I go back to the table that we use for interpretation, it was, what was it? 0.943. Okay, so looking at my table, 0.943 is between 0.8 and 1. So we have a very strong monotonic relationship. Okay, I have a very strong monotonic relationship. And I suppose I could proceed from there and actually calculate and find the relationship. Again, we're not going that far in this course, but the process would be virtually the same. We know that this relationship now exists. I might do further research or further test to decide, well, is it linear or is it quadratic? Is it exponential? You know, I know there's a monotonic relationship, but I might want to research further and find out what exactly the relationship is. Okay. Questions? Now, let me go back because I know that at least one of you came in a little bit after we started, and I want to remind you of a couple of things. One, I will post videos in the Zoom recordings folder additional videos of examples, so you'll have more than one example of both types. I'll get tonight's video posted and the note things for you. Remember that class will not meet in Zoom next Thursday. If you show up, Miss Ralston will not be here. I can assure you. I will post the Zoom recording from a previous class that covers the 1 mean and the 2 mean proportion test. It is very, very similar to the 1 mean Z and 1 mean T test. Remember the bonus opportunity. Make sure you complete your course evaluation. That link comes to your Georgia Highlands email, not to D2L. Quiz 10, which is over this topic, okay, is due by next Wednesday, which is the 19th of April. And then mini project 6, which is over correlation and regression, is due the 23rd of April, which is Sunday, a week from Sunday, actually. Questions? Thank you, Kaylee. Thank you, ladies. If you have questions, you can email. I'll be monitoring my email. I just will not be in class next Thursday. So you guys have a good evening.
Okay, bye.
Bye.